All right, welcome back. Now that we know what an IPv4 address is, what it looks like, what it's used for, and you saw how we assigned it to an IP address. We saw how we assigned it to a PC. We need to know what type of IP address we're looking at, meaning we need to learn how to classify an IP address. Okay? Now, and I get this all the time, yes, we still use class full and classless routing because we're still in IPv4. We're not fully in IPv6 yet. In IPv6, there are no classes. There are designations of IP addresses, which we'll be talking about later on in the course. But since we still use IPv4, you need to understand the classification of an IP address, or an IP version 4 address. The way you classify an IPv4 address is by looking at the first octet. So first, let's put the type of classes that we have. We have A, B, C, D, and E. And even though we don't really use the the D and the E, but you still need to know their ranges. And when I say their range, I mean the range within the first octet, all the way to the left, right? Because we got 4 octets from left to right, first, second, third, and fourth. So the range for class A is 1 through 126. What happened to 0? 0 is a default route. 0 is a reserved IP address, so it's not part of the range. What happened to 127? Well, we know that the whole 127 address is reserved for loopback purposes. So the actual address is 127.0.0.1, but you can ping 127.232.250.1 and you'll still get a reply back from that particular IP address because it's all reserved for loopback. So that's why those two are not in the range of a class A. But now since we're on the subject of the loopback address, or if you ping the loopback address or you ping loopback, what you're doing is you're testing the TCP IP stack. You're not testing your NIC card. If you ping your NIC card's IP address, then you're testing your NIC card. If you ping the loopback, you're testing the protocol suite. Okay? So keep that embedded in your head. The next range is for the B. We go there, we go from 128 to 191. That's for no surprises there. C, 192 to 223. D, 224 to 239. And let's stop here real quick. Now, maybe I'm getting a little bit ahead of myself because we haven't used the default mask or anything like that yet. But the class D range is used for multicasting. And I'll write that in there in a little bit. All right, it's used for multicasting. Now, every example in your books that they give you, they say, oh, video conferencing on your group, a range of people can actually participate in the video conference because they have one of these addresses and what have you. But these addresses, what's more important to you is in your routers, your routing protocols. And I'm going to write this down here. I'm going to put RIP, I'm going to put EIGRP, and I'm going to put OSPF. RIP uses a multicast address of 224.0.0.9. EIGRP uses 224.0.0.10. OSPF uses 224.0.0.5 and 224.0.0.6. It uses 2 different IP addresses. It all depends if it's sending it to a standard router or is it sending it to a designated router or a backup designated router. It will use the 6. So if you were to do a debug IP RIP or IP EIGRP or debug IP OSPF, you would see these updates being sent back and forth. And this is a troubleshooting technique that you would use. If you're not receiving information from a dynamic routing protocol, a network, you would go and do a debug IP, whatever routing protocol you're using, and you would see if you're getting these updates or not. You would see these particular multicast addresses that are specifically for these routing protocols. And they also have their version 6 address, which is FF02 and then the 9, FF02, and then A for 10, and then FF02 and then the 5 and the 6. So anything that starts with an FF and IPv6 is a multicast address. So multicast addresses, you will be seeing them because when you're in the router and you're looking to see if updates are being sent back and forth using the debug command, you will see these addresses. Okay, so it's important that you know these addresses because you will be asked questions on these particular addresses right here. So I'll leave them on the screen for a little bit. And then the last one, which is E, is 240 through 255. And that is in the first octet. Remember, what we're looking at here, these ranges, is because we're classifying. We're classifying an IP address to see if it's an A, a B, a C. And it's important. Why? Because each one of these has a default mask and a default host. The default mask, the dotted decimal version of it, of an A is 255.0.0.0. For B is 255.255.0.0. For C is 255.255.255.0. And for D, it is non-applicable because since it is a specialized address, it doesn't have a default mask. And E, I call that one black ops because you're not allowed to use these addresses. Even D, if you were to put something other than from A through C, your computer, your router would scream at you and say, hey, outside the normal range of addresses. It will not allow you to do it. All right, so that, and definitely E, you're not allowed to use that one at all. But the first A, B, and C, they have a default number of hosts. Now, I don't expect you to remember the exact number. As long as you know it's millions, that's fine. Unless you're taking a certification exam, like a Network Plus, that requires you to know the exact number of addresses that an A holds. It's good trivia to know. All right, B, 65,536. A comma would be nice. All right, and then 254 for the C. So you need to know this. When you're creating a network and you decide, well, we're going to use a Class C address. Everybody wants to use a Class C address. It's easy to work with. It's only in the last octet. But you don't consider the type of company you're working for, and you run out of IP Class C addresses, private Class C addresses, that is. You'd be like, uh-oh, what now? And I saw it, not saw it happen, but a student of mine who is a consultant, he came to me with that particular scenario. That one of the companies that he was working for, the previous person that set up their network didn't take in consideration the growth, the exponential growth of that company, which it was tremendous, and they ran out of IPv4, Class C IPv4 addresses. Now what? Now what? So that's why you need to understand when you're creating a network, always leave yourself room to grow. And in a certification exam is a totally different story. When we're doing subnetting and what have you, don't worry about room to grow. They ask you a particular question, you answer it to what they need. But in a real world scenario, most definitely, you give yourself room to grow. I can tell you right now, the majority of schools that I've been at, they only use Class Bs or Class As for their networks because, you know, you have hundreds, maybe thousands of students, all right? And the same thing goes for faculty. You have hundreds of faculties that are coming around. So you need to make sure, and you may have different campuses and what have you. You want to make sure that you don't run out of, especially private IPv4 addresses. All right. So this right here, what we're looking at, we'll in another section, we'll talk about the private IP address range, because there's a lot to say about that on that particular subject. But here is just the basics. We're looking at the first octet. When we see an IP address, and let me go ahead and take this out of the screen so I can write in there. If we look at an IP address and we see that it says 131 dot 131.1.2.6. What class of address is that? Well, it falls within the B range in the first octet. So you could use the default mask of a 255.255.0.0. It has the capacity of holding 65,000 plus IP addresses. This is the reason why we need to know that. So when we're creating our networks, we know, hey, if we're using a class A, that means we can have millions of addresses on our network, which you need to subnet appropriately, all right, based on departments or what have you. But we have the capacity for millions of addresses. And that's why we need to know how to classify an IP address version 4 by looking at its first octet and knowing their default mask. And just to give you a little extra, and it's not really extra, I'm sure all of you know this, CIDR, right, which is classless interdomain routing, the CIDR, that would be 8/8. Okay, I didn't mean to do that. /8 /16 and then /24. Okay, all that means that there's 8 bits on consecutively from left to right. That's where you get your 255. And the next one, you have 16 bits consecutively thereon. That's where you have your 255, 255. And the last one, class C, you have 24 bits consecutively from left to right, 255, 205, 205, and then 0. So now you know when you look at an address, what type of address you're looking at. Now, remember, there are certain addresses that we don't use that are reserved. The ones you need to know about, the 0, it's a default route. The 127.0.0.1, which is your loopback. And the other one, 169.254, and really it could be whatever number back here, it's your APIPA, your automatic private IP address, your automatic private IP address, right there, your APIPA address. Let me get out the way so you guys can see that, right? Your default route, your loopback address, and your APIPA. The APIPA, we know that we get it when we're, let's say we're plugged into a network and we're DHCP enabled. We're supposed to be getting an IP address from a DHCP server. And when we do an IP config and we see this address, right off the bat, you know that, okay, something's wrong. We're not getting an IP address because it assigned itself an APIPA address. All right? That's when we see IPv4, that's what that means, an automatic private IP address. Now, you could change that within the TCP/IP properties. And if you're DHCP enabled, you will get another tab that would allow you, let me see if, because I'm not really connected right now. I'm not really connected to a network. So if I were to be connected to a network, you can go to the properties of your TCP/IP. And if you're DHCP enabled, there's 2 tabs. The one to the right will show you advanced settings. You go in there, and there you will see that by default it chooses to give you an APIPA. But you can put manually configured, and you can put, if you're part of another network, if you leave that location, you can put the information for that particular network. So if you don't get it, because they're statically assigned. So if you don't receive an IP address from this particular location, you don't get an APIPA, you get what you manually configured. So you can tweak it to have 2 sets of networks, right? One on the main screen and one on the tab that allows you to go ahead. One is DHCP enabled, because you have to have DHCP enabled in order to get that tab. So on one, you go to your main job, let's say, your DHCP enabled, you get your IP address, what have you. And in your let's say your house, you have wireless, and then you're not DHCP enabled, everything is static because of security purposes. You manually configure your settings, and then you're still part of a network and you won't be left out. So you can do many things to help out. But know that these, and by no means are these all the addresses that are reserved. These are the main three that you need to remember, okay, for, let's say, classification or questions that they may arise on, hey, what's an APIPA or what have you. Doubtful that they'll ask you about the APIPA, possibly as far as these two addresses right here, the default route and the loopback. For sure, they may ask questions to you on those two types of addresses. All right, we will be creating default routes, so you'll see that address, and definitely you already know what the loopback is. So there you go. Those are your classes of IP addresses, their range within their first octet, their default mask in dotted decimal and CIDR notation, and the default number of hosts. All right, ladies and gentlemen, that's it for this session. I will see you in the next one.